Good morning.
Morning, sir.
Morning, Cha.
Nicholas.
What?
Okay, just wanted to see if you can hear or not.
Okay, so these are the questions from last week, which I posted. So I'm going to give you all the answers now. You all have submitted, but I just wanted to give you all the answers here as well so that we can discuss if you have any questions. Okay, so you can mark your work. I will just tell you all the answers now. Okay. So we're looking at law of conservation of momentum, and as we spoke last week, in a closed system, the total momentum before an event is equal to the total momentum after. Okay, that's the principle of conservation of momentum. Okay, so let's look at the first one. Number one is 10 meter per second. Okay, I'll read out the answers. If at any point you want to stop me, or you know what, I'll read out all the answers first. You mark, and then after that we will discuss if there's any questions. Okay, so number one is 10 meter per second. Number two is 4 meter per second. Everyone okay so far?
Yeah, Cha.
Yeah? Okay. Yeah. 10 meter per second, 4 meter per second. Number three is 1.8 meter per second. Number four is 9.4 meter per second. Number five is 3,333 kg. Number six is 13.9 meter per second. Number seven is 7.5 meter per second. And then we go to explosions. Number 8, negative 0.83 meter per second. Number 9, negative 30 meter per second. Number 10, negative 8.3 meter per second. Number 11, 500 kg. Number 12, the direction is backwards and the velocity is negative 0.05 meter per second. Okay, any question you want me to repeat the answer to?
Yes, teacher.
Which one?
Number 8.
Number 8 is negative 0.83 meter per second.
Teacher, how did you get that?
Okay, wait, before that. Anyone else want me to repeat any question? Any answer to any question?
No, Cha.
Sir.
No. Okay, let's look at number 8. Okay, I have a cannon of mass 300 kg. Okay. A cannon of mass 300 kg with a cannonball of 5 kg. Okay, so the cannon itself is 300 kg, the cannonball is 5 kg, and it is fired. The ball moves with a velocity of 50 meter per second. Calculate the recoil velocity of the cannon. Okay, anyone wants to try?
No, I got wrong also.
Okay, anyone else? Anyone else managed to get what's the answer again?
No.
Negative 0.83.
Cha, is it 300 bracket 300 V equals to 5 times 50? Then velocity equals negative 0.83.
Sorry, can you repeat that?
300 V equals to 5 times 50. Then V will equals to negative 0.83.
300 equals to 5 times 50.
300 V equals to 5 times 50.
300 V.
Yeah. Then V will be velocity.
Okay, so let's look at it. So I have a cannon, so a cannon like a gun, and then I have the cannonball inside. Okay, the cannon is 300 kg and the ball inside is 5 kg. So when you shoot the bullet, the cannonball has to come out of the cannon. Okay, so the cannon is 300. The cannon is 300, and the velocity at the start of the when the cannonball is fired is 50 meter per second. Yeah, just a moment. Okay, so I have 300 kg is the cannon, and then I have a velocity of v. Okay, because when it shoots, when the cannonball is shot, what happens is the cannon will move back. Okay, when you shoot, not just a cannon, any gun, right? When you shoot and the bullet comes off, there will be a recoil. Recoil is basically the gun moving backwards. Okay, so first thing to note is it is moving backwards, which means I'm going to get a negative answer. That's the first thing you want to note. Okay, and then I have the cannonball 5 kg is moving with a velocity of 50. So the momentum of the ball itself is 5 times 50, because mass times velocity, which is 250. Okay, 250. That is the momentum of the ball. Okay, and then the cannon is 300 kg. But do we want to find out what the velocity of the cannon is? And we know that before and after, the momentum is the same. Okay, so the momentum of the cannon itself is 300 times v. V is what we want to find, and that is equals to 250. So velocity will be 250, divide 300, you should get 0.83333, and it's a negative one because it's moving backwards.
Okay, sure.
Can I understand, Meher? Meher, can I understand?
Yes, teacher.
Okay. Anyone else?
Okay, sir.
Huh?
Teacher, number one, I
Huh?
don't know.
Number 1. Okay, let's look. Lohendra, did you ask for a question?
No, sir.
Okay, so let's look at number 1 together. Okay, I have a car of mass 1000 kg. Okay, traveling at a velocity of 20 meter per second. So 1000 kg traveling 20 meter per second. Okay, it collides with a stationary car. Stationary car means a car that is not moving. And that car is also 1000 kg, but since it's not moving, it's 0 meter per second. And then the vehicles move together after the impact. That means they stick together lah. This is similar to the trolley one last week we saw. So calculate their velocity. So let's look at, because we know that before momentum and after momentum is the same. So before momentum is, okay, car A and car B. Car A is 1000 times 20. So it's 20,000. That is the momentum. Car B, the momentum is, what is the momentum of car B?
1000 kg. It's stationary.
Stationary, so 1000 times
0.
1000 times
Sorry,
0,
sir.
which is 0 lah. So the total momentum before collision is 20,000 times plus 0, which is 20,000 lah. And that is equals to the momentum after. Now, after the impact, they move together. That means they got stuck together. So momentum after is also mass times velocity. But now the mass after the collision is 1000 plus 1000, because both the cars stuck together. So 1000 plus 1000 is
2000.
2000.
2000.
The velocity, we don't know. That's what we want to find out. So 20,000 equals to 2000 V. Okay, so V is equals to 20,000 divide 2000, which is 10. So 10 meter per second.
Number
Can
5
touch.
also.
Sorry?
Number 5.
Number 5. Okay. Who wants to try number 5? Anyone managed to get number 5? What's the answer for number 5? Huh? Number 5 is 3,333 kg. Anyone wants to explain?
No, teacher, I got it wrong.
Okay, let's look at it. Lohendra, did you get it right?
No, sir, I got it wrong.
No. Nicholas?
I got 3.33 in grams. I didn't convert it to a kg.
Okay, kg. Okay. Beatrice, did you manage to get 3,333?
No, I
No.
got 333 instead.
333. Okay, let's see. Wingen, did you manage to get 3,333?
No, sure.
No. Okay, let's look at it. Okay, I have a lorry. Mass is 12,000 kg. And then I have it traveling at 15 meters per second. And then I have a stationary car. Stationary car of mass, no, sorry. No, number what? Number 6, right?
Number
Oh,
5, teacher.
Number 5, sorry, okay. Okay, I have a van, 5,000 kg. Okay. And it's traveling at 10 meters per second, collides with a stationary car. Collide means go and hit lah. So the car is stationary, meaning the velocity of the car at the start is how many?
10.
The car is stationary. So what is the speed of the car? 0, because it's not moving. Okay, I don't know what is the mass of the car because that's what I want to find out. The vehicles move together after the impact at a velocity of 6. So after the impact, they move together, that means they're stuck. So if they got stuck together means their momentum will be mass times velocity. Mass will be 5,000 of the van plus width. I don't know what's the velocity, the mass of the car. So I just put X in bracket, and then they are moving at an impact of velocity of 6 meters per second. Okay, so which means, let me just take another. Okay, I'm just going to scroll down here. Okay, so the momentum before, everyone can see me typing?
Yes, sure.
Yes, sir.
So momentum before equals to momentum
Yes.
after. So momentum before is mass times velocity. So we have looked at it separately. So the van, mass times velocity, plus with the velocity of the mass of the car, I don't know, and is 0. X times 0, which is 0 lah. And then the total momentum after will be, because they stuck together, is 500 plus X, which is the mass of the car, times with 6, because 6 is the velocity. So you want to find what X is. So far, everyone can follow?
Yes.
Yes.
So 5, 1, 2, 3, 4, 1, 2, 3, 4, 5,000 is equals to,
Huh?
so I open bracket, 50,000.
Oh,
And then I
sorry.
open bracket on the right hand side, 6 times 5,000, 50,000.
50.
And then plus with 6x. Okay? So, and then 6x equals to 50 minus 30,000 is 20,000.
20,000.
So x is equals to 20,000 divided 6. So you get 3333.333 kg. So you just put 3333 kg lah.
Sure.
Okay, Tachu can?
Wait,
Yes, teacher.
Miss Sharina,
Yes.
where you get the 30,000?
Because this is do you understand why the first line of the information, the first line of the formula?
Yeah.
Then 6 times 5,000,
Okay.
because I need to open bracket like maths.
Okay.
And then the 6 with the 5,000 is 30,000. 6 with the x is 6x.
Okay.
Okay.
Sir, what's the look?
I don't know lah. Did he reply on the group?
No, sir.
Hey.
Oh, okay, never mind lah. Okay, anyone else has any other question?
No.
No, sir.
Sir.
All okay?
Yes.
Yes.
Okay.
Teacher, it's not the method that you showed, right?
Yes.
Right.
Does it work for all the questions?
Which method?
The one you just showed, the answer. Question
The-
5 just.
Yeah. Is
Yeah.
it the same method?
Yeah.
For 1 to 7, it is this concept because no. Yeah, it's this concept. You just have to see whether they stick together or they are separate, but it's basically essentially it lah. Then I guess the unknown is the one changing. Here it's the mass of the car. Sometimes it's the velocity that they're asking for.
Oh, okay, teacher.
Yeah, in this case, I have stationary car, stationary motorbike, stationary, this one also stationary, stationary. This one is moving. Moving. Okay? Okay, if there's no other questions, then we will look at a past year paper. Okay. Close this. Okay. Okay. I will. Okay, I'll tell you what. I will. How many of y'all are on your phones?
Me.
May I hack some more?
Wait, sir, the one who are using phone for Zoom or?
Yeah, phone for Zoom.
Oh, okay.
Okay, now when if that's the case, okay, I put these questions here. Okay, you write your answers. Write your answers in your book, and then we'll discuss. Maybe like these questions, I'll give you all maybe like 5 to 7 minutes, and then I will scroll down lah. Okay.
Yes, sir.
Teacher.
Okay, so you can start doing. Yeah, write your answers in the book, and then yeah, we'll discuss.
Okay, teacher.
Okay, can I have a show of hands of those who are still doing this part? Now I will scroll down. So you raise your hand. Oh, okay, still doing, okay. I'll keep doing.
Teacher B also do right.
Yeah lah.
Ah,
Yeah lah.
okay, okay.
Yes,
Just stare at it.
A and B, everything.
Jadi talking on. Oh, okay, never. Never.
Try done.
Teacher done also.
Okay, all okay?
Yes.
Okay. Can I scroll? Can I see a show of hands of those who are still doing this part? You know, I will scroll. No, okay, all done. Okay. Yeah.
Huh?
I'll move to this one. Number 3. 3B.
Okay.
Okay, you guys okay? Or still doing? Can I have a show of
You're
hands?
done.
Anyone still doing? Please raise.
Done.
Okay, I'll scroll down. Okay. Oh. Okay, number 4.
Teacher can go toilet ah? Teacher.
Can.
Thank you, teacher.
Okay, can I have a show of hands for those who are still doing? Okay, still doing. Okay, I'll give you a couple minutes more.
Sure, done.
Okay, anyone else still doing? Okay, Noah, I'll I think this paper, the rest you all cannot do yet. I mean, not covered yet. So let's discuss first, lah. Okay, we discuss this question, and then we'll do another paper. Okay, so let's look at this. Speed is a scalar quantity and velocity is a vector quantity. Wait, just a moment. Guys, just a moment. I have a bit of an emergency. Just please hold on for a while.
Sure, sure.
Right. Go. Loindra, what question you want to ask me?
Okay, let's continue. So let's discuss. Speed is a scalar quantity and velocity is a vector quantity. How is a scalar quantity different from a vector quantity?
Vector quantity has magnitude and direction, while scalar quantity has magnitude and no direction.
Correct? Okay. Next, underline the two scalar quantities in the list below.
Energy and temperature.
I said energy and force.
Energy and temperature.
Yeah.
I got it wrong.
Air resistance, what is the direction? That has direction. So energy and temperature. Temperature has no.
I wrote temperature before and I erased it. Wow.
Teacher, force no.
Force no. Because force you have upward force, downward force, gravity is down, weight is down, drag is up. So it has direction. There's energy and temperature.
So basically, scalar quantity has no direction, but vector quantity has a direction.
Yes. No. Scalar quantity has no scalar quantity no direction. Vector quantity got direction, magnitude and direction. Scalar is just number, no direction. Like you don't say it's 200 degrees Celsius facing north. You know what I mean? There's no direction for temperature. Just
Yes.
200 degrees Celsius. So that's what it means. Whereas force, okay, gravity is acting downwards. You know, so there is a direction.
Okay, Cha, thank you.
Next one, a boat is moving at constant speed. Sketch a distance time graph for the object, for the boat, sorry.
Is it a straight line?
Yeah. It's a straight.
Yay.
It will look something like this. Constant speed means the gradient will be constant, which means it will be a linear graph, a linear line.
Okay, Cha.
Okay, let's continue. Okay, let's look at this. I have collision between two blocks, A and B, on a smooth horizontal surface. Before collision, and then I have after collision. Okay, before collision, block A, mass 2.4 kg, moving 3 meters per second. Block B is not moving, it's at rest. After collision, they stick together and move. What is the momentum of block A before collision?
Cha, I got 0.4.
Is it 7?
7.2.
Yeah, 7.2 kg meter per second.
How did you get that?
Mehak, the question says momentum of block A before collision. Block A, momentum is mass times velocity.
I divided it.
2.4 times 3.
Okay, Cha.
Okay, 7.2 kg meter per second. Make sure your unit is there.
Yay. Is that the momentum, Cha?
Yeah, momentum of block A.
7 point. Okay.
7.2.
Okay. Yay.
7.2 kg meter per second.
Yes. Okay, then what is the velocity V? After
Velocity, I think it's 2.
Is it 3.6?
you should get 2.
I got 2.
2, 2, 2.
6.
2.
2. So before collision, the momentum is 7.2 because B has no momentum. After collision, I take 7.2 divided by
3.6.
total mass, which is 2.4 plus 1.2, which is 3.6
Yay!
meter per
It
second.
is 2.
meter per second. 2 meter per second.
Okay, okay. Meter per second. Meter per second.
Answer is so 3.2.
2, the answer is 2.
Oh,
E.
Beatrice, okay? Ringyan, okay?
Yes, sure.
Yeah, sure.
So let's continue. A balloon contains a fixed mass of gas. Explain in terms of momentum of molecules how the gas in balloon exerts pressure.
Particles collide each other and on the walls of the balloon.
Okay, now they're saying in terms of momentum of molecules. So when we look at momentum, it's mass times velocity. So when you say the molecules are colliding, okay, that is because there is a, when they are colliding, what is changing? When they're hitting the walls of the container, they are moving. Their speed will change, which means there will be a change in momentum. Okay,
Please what's the answer?
What?
Correct answer.
There is a change of momentum during collision.
Slowly. Please.
Change of momentum during collision.
Okay.
As the molecules hit the wall.
Eat the wall. Okay.
This causes pressure to the walls of the balloon.
I said bounces off the walls of the balloon. So does it?
Yes, but you must mention that there is a change of momentum during collision.
Okay, done.
Because it says explain in terms of momentum. You have to mention momentum. Okay. Explain in terms of molecules why the pressure of the gas increases when the volume of the balloon decreases. The temperature of the gas is constant. So why when the volume of the balloon decreases, so basically when the balloon gets smaller, why does the pressure increase?
because then the gas molecules will collide more.
Okay, so so what we want to say is this is the term that you must use: frequency of collision. That means the collision frequency is more. So the frequency of collision of molecules with the walls, frequency of collision of molecules with the wall.
Adapla.
Two.
You're asking me.
Sorry.
Oh my god.
Sorry.
Tachu.
Very noisy.
Okay, so I
See that.
frequency of collision of molecules with walls increases. Frequency of collision of molecules with walls increases. Okay, continue. When volume of balloon decreases, the area of contact is smaller. When volume of balloon decreases, the area of contact is smaller. while the force caused by the molecules increases. While the force caused by the molecules increases. This increases the pressure of the gas.
Teacher,
Hmm.
while the force caused by the molecules
Increases.
increases,
This causes the pressure of the gas to increase. So I'm using the concept of pressure equals to force over area, where my area is small, my pressure is large, and linking that to molecules, because the question says in terms of molecules. Okay, let's look at C. The initial volume of the gas is 500 cm cube, and the pressure is 1.1 and times 10 to the power of 5 Pascal. The volume is reduced to 200 and the temperature of gas is constant. So what is the new pressure?
is it 1100?
No,
Is it 550?
no. Okay, see, from 500, they're going to 200. Correct? Which means the volume is decreasing. That means my pressure is going to increase. So 500 becomes 200. 1.1 times 10 to the power of 5 is going to become what? So you use ratio. So 500 to 200, if you see 500 to become 200, I multiply by 2.5. Because 500 divide 200 is 2.5. So from 500 to become 200 is 2.5. So my pressure also I times with 2.5. I'm using ratio. So 1.1 times 10 to the power of 5, I times with 2.5. I will get 275,000 Pascal. That will be my new pressure.
Sure, are you typing?
No, I'm not typing.
Oh, okay.
I'm just telling you all. From 500 to become 200, I'm using ratio. 500 to become 200 is 2.5. So 1.1 times 10 to the power of 5, I times 2.5 to get my new pressure. Because 500 times 2.5 is 200. So 1.1 times 10 to the power of 5 times 2.5 is 275,000 Pascal. It's like 5 apples is 10 ringgit. 2 apples is how many ringgit, like that. So 500 cm cube, the pressure is 1.1 times 10 to the power of 5. So if it's 200 cm cube, what is the pressure?
Okay.
Yeah. Okay, all okay so far?
Yes.
Yes, sir.
Yes. Okay. Can take a 5-minute break, come back, and then we'll do another paper. Okay?
Okay, sure.
Come back at 10, now it's 10:12. Come back at 10:17 now.
Okay, sure.
Okay, everyone back?
Yes.
Gotcha.
Yes, sir.
Okay, I'm going to share my screen and we're going to do another paper. Okay, let's do this. Okay.
We have to draw the graph.
Yes, you'll have to draw the graph. I don't think you need a graph paper for it though. Just estimate lah and draw. Yeah, I don't need the small boxes. Okay.
Teacher.
Okay, can I have a show of hands of those who are still doing? Okay, I'll give you a couple minutes more and then we will, then I'll scroll down.
Done, Chair.
Okay, how about Nicholas?
Done, Chair.
Okay. Okay, part 2. Okay, are you all done? Can I have a show of hands of those who are still doing? Okay. Okay, number 2. Okay, still doing?
I'm done, Chair.
Can I have a show of hands if you're still doing?
About that.
Okay, number 3. Okay, let's discuss.
Teacher.
Okay, Chair.
Okay, Chair.
Okay, define acceleration.
The rate of change of an object's velocity.
Okay, correct. So rate of change of velocity. Okay, B. Speed time axis for the graph of motion of car. The car starts from rest, and then they give you the time, and then constant acceleration and all that. So now, it's a speed time graph. So from 0 to 15 seconds, the car has a constant acceleration. Constant acceleration to a speed of 28 meters per second. What does constant acceleration mean? What does that mean for my graph?
That your speed is
Going in a it's going in a constant speed. It's just going up in a straight line.
Okay, so because it's a speed time graph and acceleration speed over time or change in velocity over time, acceleration is essentially the gradient of this graph. So if acceleration is going to be constant, that means my gradient is going to be constant. That means my graph is going to be a linear graph. So I'm going to have something like this. Going up until 15 seconds and at 28. Okay, so that's 0 to 15 seconds. And then from 15 to 32, the car is constant speed. So it will be a, what will it be now?
On straight line.
So it will be a straight line until it says 32 seconds. Yeah. Okay. And then from time 32, the car has a constant deceleration until it comes to rest. So it comes to rest means the speed is going to be 0. But it says the car has a constant deceleration to rest. So until what time? So I have to draw a line going down, but until how many seconds? When 30 the graph? Because it says from 32. So I know my graph is going to go down because it's deceleration, constant deceleration. And it will go to 0, but where? How many? Is it 50 seconds? Or at 40 seconds? Or 45?
It's
Then
near the
how much is
40 seconds.
2 meters second, 2 meter per second? And you
Correct.
follow.
Calculate. No, you need to calculate. So I have, the car has a constant deceleration, okay, of 2 until it comes to rest. Okay, so from 28, so from 28, I'm going down to a speed of 0.
That's
Okay,
28 actually.
from 28 because it's here is 28. What? Up here is 28. So from 28, I'm decelerating, I'm going down until it comes to a rest. So from 28 meter per second, it's becoming 0 meter per second. My deceleration is 2. So based on the formula, acceleration is change in velocity over time. So my change in velocity is 28 to 0. That means my change in velocity is 28. Now I want to calculate my time. My deceleration is 2. So 2 equals to 28 divide time. So my time will be 28 divide 2. Do you all understand what I'm saying, or you all don't understand?
Understand, Jeff.
Understand.
Understand, sir.
Acceleration is equal to change in velocity over time. Change in velocity is 28 to 0, so 28. Time I want to find out, my acceleration, or in this case deceleration, is 2. So 2 equals to 28 over t, time. So time equals to 28 divide 2. 28 divide 2 is 14. That means for 14 seconds, after 14 seconds, it will come to rest. So from 32, I must draw my graph all the way to how many seconds? 46. It was 14 seconds. So here, I go all the way to, this is 41, 42, 43, 44, 45, 46. Okay, can I understand?
Yes.
Yeah.
Okay. That's why it says here, using the space below for calculation, because you're supposed to calculate that.
Teacher.
Let's continue. Okay, from time 15 to 32, which is that constant speed, the path of the car is part of a circle. So it's going in a circle. So let's say it's going in a roundabout. So for this motion, what is the direction of the resultant force on the car? So when I have a circle, when I have like the centripetal force, if you remember from 2 years ago, when you have a circle, a car moving in a circle, or anything moving in a circle, the resultant force is always acting towards.
The middle, the center.
So the direction of resultant force of the car on the car is towards the center of the circle. That's the direction of the circle. Okay, and then what happens to the velocity of the car? So imagine a car going around the roundabout. Okay, so the accelerator is being pressed and then it's going around the roundabout. But it says that the speed is constant from 15 to 32. So what happened to the velocity there?
Constant as well.
What is the, no, so because they're going around the roundabout, right? What does the velocity help to do?
Velocity stays the same.
Now, what does the velocity? The speed is the same, but what does the velocity? What does the velocity help the car with?
Keep it.
How is it constant? Imagine you're driving a car and you're going around the roundabout. In that whole roundabout, what is changing? Every single
The direction.
direction is changing. As you go in circle, right, the wheel is turning a bit to the right, or left, a bit. It's changed. The direction is changing constantly. So that is why the speed is the same, because what happens to the velocity of the car is the velocity continuously changes the direction of the car. Okay, so that's the answer. What happens to the velocity of the car? The velocity is continually changing its direction, the direction.
Okay, all okay?
Yes.
Okay. Number 2. I'm not sure if y'all learned this or not. Let's just see what y'all came up with. Okay, a force is used to move an object from the Earth's surface to a greater height. Why the GPE of the object increases?
Because it's further away from the center of the earth.
Okay, correct. It's further away from the center of the Earth. And actually, this question, right? We will look at another aspect of it later on. So I always this. We'll actually learn this later on. But yeah, that's the right answer. I mean, for now, as of what you want to know, is going away further away from the center of the Earth, so the GPE increases. Okay. B. The train moved up towards the mountain. 80 passengers, each of average 65, through a vertical height of 1,600. Calculate the GPE increase. Does anyone know how to do this?
Because the center of the gravity is in, I mean the source of the gravity is the center of the earth.
I'm doing B, Lohendra.
Oh, sorry, sir.
So is it 20?
How did you get 20?
I did 1,600 divided by
80. Then the 65?
No, not quite. Okay, actually, I'm supposed to teach you all this later. I forgot that I teach you all. It's in another chapter. But I'll just tell you all, okay? So what you want to do is you want to, there's a formula for it. It's MGH. Okay?
MGH.
So is it
Yes.
1,019,200? 1,019,200.
1 million. You have to take M, G, and H. This is the formula for potential. So MGH, so I take mass, which is 80 times 65, because 65 is one person's average. 80 passengers. So 80 times 65 times G, gravitational acceleration, is 10, and times height, which is 1,600 meters. So 80 times 65 times 10 times 1,600 is equal to 8 point. Sorry?
832,000,000.
Change it to 8.32 times 10 to the power of 7.
So how do you change it?
We will look at this in another.
A standard form.
Oh, okay.
Okay. Okay, this one you all should know how to do. 3A. Complete the statement by writing in the blank space. The moment of a force about a pivot is equal to what multiplied by what? What's the answer? The moment of force about a pivot is equal to?
Times velocity.
Sorry?
Multiplied by velocity.
No, that is momentum.
You.
This is
Radius multiplied by force.
Yes.
force multiplied by perpendicular distance from the pivot. Remember when we did Star Wars thing?
Yes.
Yeah, I wrote force and distance only.
You have to write distance, perpendicular distance from the pivot.
Okay.
From where? Okay, so the moment of the force about a pivot is equal to the force multiplied by the perpendicular distance from the pivot.
Perpendicular.
Distance from the pivot.
Okay. Thank you, Joe.
Next one. Figure 3.1 shows a horizontal rod of length 2.4, weight 160 Newton. The weight of the rod acts at its center. The rod is suspended by two vertical ropes X and Y. Tension is 80 on each. What is the name given to the point at which the weight of the rod acts? What is that point called? Anyone? Weight of the rod acts at the center. So what is this point called? Center of?
Center of mass.
Gravity. Oh, center of mass. Sorry.
Name
Center of
given
mass.
center of
Center of mass.
mass.
Center of gravity.
Pivot. I don't know.
Good.
Center of mass. Okay, calculate the mass of the rod. So given the weight is 160, so what is the mass?
160 Newton to kg.
160? So 160 Newton, I must change to kg. What do I do?
Newton change to kg.
Sorry?
Divide by 1,000.
Divide.
Divide by 10. Divide by 10. Mass to go to weight, you times 10. Because you times
Oh.
gravity.
Oh.
So from weight to mass, you take 160 Newton divide 10. That means the mass is 16 kg.
Teacher,
Yes,
what is BI? B1?
center of mass.
Okay. Thank you, teacher.
Okay, last one. The rod is in equilibrium. Okay, that means it's not moving to the anti-clockwise or clockwise. Okay, remember what we did in that Star Wars thing, huh? Okay, now, using data from figure 3.1, so using all these things, because it specifically says used from there, so you have to explain in terms of the numbers and everything. Explain why the rod is in equilibrium.
Because
Because
both
both sides.
the rope are equal weight.
Thanks, Landra.
You're welcome.
And the distance is equal.
The distance away from the pivot is equal. Ha.
So I just said the distance is equal.
You didn't say the pivot. Psych.
Wow.
What else?
If you divide 160 by 2, it's 80 and 80.
What are you saying?
That's a point that you need to note as well. So that's the first thing. That's the first thing you want to mention. Okay.
First thing, the length of the rod.
So now 80 on X and 80 on Y is equal to 160 at the bottom. Okay, so the first thing you want to say is that upward force
I did
is
opposite way.
80, which is 160. Downward force is also 160. So the resultant force is, what is the resultant force?
0.
0, correct. So the first point you want to state is that there is no resultant force.
Okay.
Okay, continued by saying rope X and rope X is 80 Newton, rope Y 80 Newton, and that together they equate to 160 Newton, which is the weight of the rod. This is to explain why there's no resultant force. Okay. And then look at the moment. Okay. Remember, moment is force times perpendicular distance. Okay. So let's look at rope X, that side, the left-hand side. Okay. What is the moment there? Force 80 times distance. What is the distance from the pivot? No. From the pivot to rope X, what is the distance?
2.4 divided by 2.
Correct. Because 160 is at the center, so half of it is 1.2. So the moment on the left-hand side is 80 times 1.2. The moment on the right-hand side is also 80 times 1.2, which means the anti-clockwise moment is equal to the clockwise moment.
Clockwise moment.
You want to mention that as well. Remember we looked at this during the Star Wars presentation?
Yes, sure.
You want to note that anti-clockwise moment is equals to clockwise moment because on both sides is 80 times 1.2. Okay?
Yes.
Any questions?
No, teacher.
No, sir.
No. Beatrice and Wingyan, okay?
Yes, sir.
Yeah, sure.
Okay. Then that's all for today. Yeah, that is all for today's class. I will post more questions and then we'll discuss as we go along. Okay. I'm sorry
Okay,
about
sir.
earlier emergency. But yeah.
Teacher.
That's all for today. Thank you so much.
Thank you, teacher.
Teacher.
Take care.
Bye.
My teacher.